do is make a big table of, like, say, the 10,000 most common passwords and pre-compute their hashes and then compare to the stolen hashes. Salt is something the web server is going to automatically add to your password so that you don't have a common password. But, as we saw, in order to be able to log in, you have to store the salt unencrypted or unhashed. So then how does salt help? If they've stolen the database, then they get the salt as well. Here's a rainbow attack without salt. So basically, you take the however many common passwords you think are useful and compute hashes for them. The cost of this is greatly dominated by the cost of computing the hash, because it's intentionally expensive to compute these hashes. So the cost of the hash function times the number of common passwords is basically the dominant factor in the cost of it. All right, so this hash column is the only expensive part here. With salt, yes, you know the salt, so you know what to prepend to the common password, but you have to do that for every salt that you've stolen. So it's about the same cost to compute to find one stolen password. It's like one salt times however many common passwords you're checking. But that only gives you one password. Compared to this rainbow table, this gives you every password for someone that's used a common password. With salt, you have to basically make that rainbow table for every single user. So now the cost is cost of the hash function times number of common passwords times number of stolen salts. It's basically just in that table is going to determine how expensive your brute force attack is. Okay, and then with Pepper, they can't do anything at all unless they have also found and stolen the pepper. And that's the whole point of Pepper, is that it's somewhere else. So it kind of separates the vulnerability into two different places, so that if you manage to attack one place, it still gets you nothing.
Is pepper added with the salt or after?
Pepper is added with the salt, yeah. So whether it goes before or after doesn't really matter. They're usually prepended. So I believe pepper and then salt and then password is a common way to do it.
How often is pepper used? Like, is it as ubiquitous as salt? Because when people talk about breaches, they're like, the passwords were hashed, were salted, or they weren't salted.
Yeah. So how common is pepper? And you're right. You usually hear about salt, but you don't often hear about pepper. For any big major Facebook or Google or something like that, it's a safe bet that they're using Pepper. They're not going to advertise the fact that they are, but I can't say this for certain, but I believe it's as common as salting for like the big major organizations. If you're making some small little thing, then maybe you don't use Pepper. Like in your senior projects, you'll probably just use whatever some API gives you, like ASP.NET. Okay. And all of this stuff is just handled by the key derivation function. So whatever the key derivation function does, it probably is different between all the various web servers out there. But its job is basically these three things: salting, maybe peppering, and hashing with an expensive hash. So this brings up another question, though. All of this stuff we've been talking about, this is all done on the web server. So the KDF is on the web server. Does that mean that your password is vulnerable until it reaches the web server? So there's still this whole issue we haven't even discussed, which is you're a client and you're sending your password to the web server before that KDF ever runs. So maybe you type in some really bad password, just the word password, and send it off to the web server. is it actually vulnerable until reaching it? And the problem there is that it's not a direct line like this. There's an internet full of hackers in between you and the web server. They could easily just intercept your communication. Yeah.
Could you use a smaller scale KDF on the client side before you send it?
So would you use some kind of KDF on the client side before sending it? Right idea, basically, except it's not actually a KDF. It's essentially the same idea. But basically what we do is we just use an encrypted socket. Same idea. It's kind of like scrambling the information so that if somebody steals it, all they get is garbage. And basically, though, this is just HTTPS. That means your HTTP communications are encrypted. This has nothing to do with the KDF on the server side. So this is unrelated to storing passwords. This is unrelated to databases. Like, you want any communication with a web server to be secure, like credit card numbers, social security numbers, not just passwords. Okay, so now the server and client both have an encrypted socket. So both of them are encrypting before sending anything and decrypting after receiving. So both ways of this communication are encrypted. Now, so yeah, HTTPS is pretty much ubiquitous now. Like, it'd be actually kind of hard to find a website that's using plain old HTTP, just because you might as well. It's there, it's well established. All you have to do is put that little S on the end. The web server has to do a couple additional little things to make it work, but it's basically free. But going back to this, so if there's an entire internet in between you and the server, and if you're encrypting everything, then how do the routers work? Like, how do the routers, if all of your information is encrypted, how does the router know where to send it? So that's not fully how an encrypted socket works. So it'll use something called transport layer security, or you may have heard of SSL, Secure Sockets Layer. TSL is kind of the successor to SSL. It's separate from TCP, but it is aware of TCP in some sense. Basically what it works is it kind of in tandem with the TCP handshake. There are additional steps in order to exchange keys to make the encryption work. And then all it does is it leaves the TCP part alone and the IP part alone, so it doesn't encrypt the packet headers. That's how the routers know where to send your information. It can't be encrypted because the router has to know where to send your stuff. But then everything in that packet, so the payload, is completely encrypted. That includes all of the HTTP headers, not just the HTTP payload. So the internet protocol stack is many levels deep. There's like the transport layer, there's the IP layer, there's the HTTP layer. Everything inside of the TCP packet is encrypted, so that means they don't even know that you're doing an HTTP GET versus an HTTP POST or anything like that, because even that part of it is encrypted. Okay? And it's just we need these green parts to remain unencrypted so that the routers work, because otherwise every single router in between you and the server would also have to have the keys for your encryption. And you don't even know what those routers might be. It's dynamic and it can change. Okay, so this is kind of unrelated to databases specifically, but kind of tangential. We are concerned about passwords and how to store them in a database. It's important that we don't just send plain text passwords before getting there, which is also would be a huge vulnerability. Okay, so any questions there? Yeah.
Just out of curiosity, how is HTTPS, what is the method of encryption?
What is the method of encryption? It's basically a key pair exchange using something like, so various algorithms for doing this, like Diffie-Hellman. If you take the networking class, you'll learn all about that kind of stuff, but kind of beyond the scope of this. Encryption is super interesting, actually, more than it sounds. Like, it's brilliant, like the people who figured this stuff out. Okay, so we've been talking about all the threats and the defenses against those threats are based on what if somebody steals your database. That's obviously a big one and bad. But there are other kinds of threats that don't even require stealing anything. Like, you could just sit there with a web browser open. If you know somebody's Facebook username, you could just sit there and type in passwords all day long, trying over and over again. You're unlikely to ever find it, but if you do it in an automated way with a computer, just brute force, try tons of combinations of passwords, then you might eventually find someone's password. So threats like that don't even require stealing data, we have to protect against them too. So a few little additional steps that you've probably heard of. So like locking out login attempts after a certain number of tries. So if you're trying to do a brute force attack, you only get 5 tries, and then you're locked out for like an hour. So let's say you would need to try like billions of combinations before you actually find a password. Then this is going to take you a billion hours, which is longer than a human lifetime. Two-factor authentication. So even if somebody does figure out your password somehow, that's not enough to get in. This is kind of the same idea as Pepper. Is like you have to steal 2 things now instead of just one. You would have to steal their password and their phone in order to get in. Has anyone been around long enough before the U started requiring 2-factor? Yeah, some people. It was only like a few years ago, and so it's super annoying. And you can basically thank people who use dumb passwords for this. This is why you have to use 2-factor now. IT just got sick of people just guessing common passwords and getting into some student's account, or even worse, into a professor's account. It happened all the time, they claim. So they finally just forced 2-factor authentication. Another thing you can do is so let's say you steal a password, the first thing you would probably want to do is change it so that the other person can't change it first if they somehow know that you stole their password. So what you can do there is kind of like 2-factor authentication, where you require like an email to reset the password. That way they would have to have access to your email account as well as whatever account they stole. Okay. All of this stuff, like, is email authentication required? Is 2-factor authentication required? How many login attempts do they get? What's the minimum password length? What's the minimum password complexity? Stuff like that. All of that is configurable in the .NET MVC web server project. There are just all these little options you can set. And you'll see those in the Phase 3 handout that will come soon. You can play around with those, but when you hand in your Phase 3, we do want kind of minimal security set on the passwords so that we don't have to type some complex thing with like a bunch of ampersands and whatever when grading. We have to be able to quickly create an account through your LMS, so we're going to ask that you crank the security knob way down just for grading purposes. So keep in mind that's not something you would want to do in the real world, but this is school, so we have to make compromises. Okay, so any questions on that password security stuff before we totally switch gears? Okay. So testing is a critical component of any software development. And doing it when there's a database involved actually adds some interesting wrinkles to the problem. So, just very brief recap. So there are lots of kinds of testing, and these are not like mutually exclusive. So you can do black box unit testing or black box regression testing. Unit testing is pretty much the main driver behind most tests. So we won't talk specifically about like, well, what are the interesting parts of black box testing as it relates to a database, because there kind of aren't really any. Where it gets interesting is, how does unit testing work when there's a database involved? And regression testing is just, whatever tests you have, just keep them around forever and run old tests periodically. Okay, so this is one of the reasons why MVC is great, is it makes testing of a web server possible. Imagine all of your logic code, all of your code was just kind of lumped together into one place. Then you wouldn't be able to test it without like opening a web browser and clicking on things and typing things. So MVC separates the logic into controllers that we can just give fake data. Instead of having the web browser generate the data, we can just write a test that has fake inputs. So basically, the parts we're going to focus on testing are the controllers. Okay, so that might look like in your library assignment that you're working on right now, there's a homecontroller.checkoutBook, which takes in a serial number. And so you could write a unit test that invokes that function and then does some assertions on whatever happened. The way the web server works as is nobody's ever directly invoking checkout book. That's just happening when you click on a button on the web page. But since it's MVC, this is just a standalone method, and you can just invoke it directly. You can pass in some hard-coded serial number. Okay. So, a couple of problems because there's a database involved. First is a unit test has to have a known outcome. You have to be able to assert something. Like, I expect the result to be 7. Was the result 7? With a database that's that has users, say you'd have a bunch of users for your library, checking out, returning books, things like that. You don't know what the known outcome would be. Say your test is verifying that after calling checkout book on serial number 1005, you assert that the number of checked out books is 1, but it might be more than that because somebody might have checked out some books. The other problem is your tests have side effects. So some of them won't. Some of them are just like select some data, but some of them are insert or delete some data, check out or return a book. You don't want your unit tests affecting what the users see on the live web server. If I happen to be running some unit tests that check out a book, and then some actual user goes and tries to check out that book, it'll look like somebody else has it. That's obviously bad. So, a few possible solutions to this issue. You could, instead of using the live database, you could just use kind of a copy of it that's only for testing purposes. So you actually make another MySQL server and make a database with all the same schemas, put some basic information in there, and then every time you run your unit tests, you would first have to make sure to reset that database to some known state. Because that's the point of a test, is you need a known outcome. So you need to know, like, there are 7 books, 3 of them are checked out or whatever. But you could do that. You could write a function that does, delete everything from all the tables, insert all this known information. Some problems with that first, unit tests should be very fast, ideally. And going to an actual database, like across the network, is slow. Maybe no way to get around that, but if we can, it would be great. This is going to slow down your unit tests a lot, and discouraging running tests is always a bad thing. And unit tests being slow is going to discourage people from running them. And then the other problem is the inputs to your test are not encoded in the test itself. The inputs are in the database. So when you're writing your unit test, normally you do something like set up some simple objects inside of the test, then do some assertions on those objects. In this case, the objects that you're testing against are in the database. So you don't really know inside of the source code of the test, you don't know what the inputs are. You would just have to you'd have to go look at like whatever script sets up the database to know what to assert, like how many books are there in the database. Another possible solution is in your controllers, kind of separate them out into two helper methods, one that does the database stuff and one that does the rest of the logic. So you can then write unit tests only on the logic helper. So you would not write a unit test that invokes this whole controller. You would write a unit test that just invokes do logic. Then you can pass it in fake data and just avoid the database altogether. Problems with that is this is not testing your link queries or your SQL queries, whatever they may be. So this is probably my least favorite option. And it kind of just makes the code messier. Okay, third option is it's similar to option one, where you're using a different database. But instead of using an actual MySQL served database, you use what's called a mock database. And so a mock database is like solely for the purposes of testing, and it's usually just in memory. So there's no server involved. There's just some software, some libraries that implement the same functionality as a database, but it just keeps all the stuff in memory. So the testing database is obviously going to be much smaller than the real database, but that's okay because they're unit tests. The entire thing has to fit in memory, so that limits it. But doing kinds of like performance tests you wouldn't do with this. If you're doing performance tests, you would use an actual real database with billions of rows. Okay, so a mock database, there are lots of providers of these. .NET has one. And basically the way it works is your existing link queries, instead of going through some SQL translator, they go into a mock database translator. So your exact same queries work exactly the same way, and you don't have to really do anything. You just kind of point it to a different place. Point it to the in-memory database instead of the server database. The one downside to this is now that you're putting a lot of trust into the link to SQL translation, because you're not actually running SQL commands on a real server. You're running the same link queries, but they're being translated in a different way. Was there a question right there?
Where is this mock database hosted?
Where is the mock database hosted? On your machine. So it's actually just like kind of built into your unit test framework, and it's just in memory.
So it's like a local host.
Yep, it's kind of like a local database server that runs only while you're running your unit tests.
And is it persistent?
Is it persistent? It can be persistent between tests, but you usually don't want it to be. You usually want tests to be self-contained. So you make a mock database, do your tests, and then throw it away. This downside, however, is it's kind of not really our problem. We are not testing the link to SQL compiler. We just have to trust that it works. Kind of like when you're writing unit tests for anything, you're just trusting that the compiler works. Your goal is not to test the compiler. Your goal is to test your software. Even there, like, you're also kind of testing that the CPU works. Like, do the instructions execute? You have to just kind of trust these layers of abstraction that are below you and test only your part of it. Otherwise, none of this would ever work. Okay, so this idea of a mock database, it's not actually running on some remote server. It has the same schemas as the real database, and it actually just gets them out of the same scaffolding process. So thus, since it's using the same scaffold models, it works with the same link queries in your controller. So you don't have to change anything. It's usually small, like a handful of rows here and there, and you usually build one per test. And they don't always, but they can reside in memory. If you make a big mock database, then it may not reside in memory. But the advantage of that is that it's now way faster than actually running SQL queries. One possible problem is, depending on the implementation of the mock database, it may not actually be relational. So it supports all of the same sorts of queries, like joins and distinct and stuff like that. But the one that's actually built into .NET is not relational, so it doesn't actually enforce referential integrity, like foreign key constraints. That's kind of a problem, because part of the thing you might want to test is, are your foreign key constraints working correctly? So what I recommend, the testing solution, is two things: a mock database for like your suite of tests that you run like every day or every build or something like that, plus an actual test database using a real MySQL server, so that you can verify that your queries are all formulated properly with regards to referential integrity, key constraints, and things like that. The good news is that actual database tests, you only need to run those when something about the database changes, like the schemas, or you're adding a new query or changed an existing query. Then you'll go and rerun those. But the other unit tests that are more about testing, like is your controller logic doing the right things with the data returned from a database, you can run those all day, every day on the mock database, and it'll be fast. Okay. Another issue related to the fact that, related to web servers specifically, is these controllers that you're working on. Let's go and look at one. So here's home controller for the library. It's returning, and I've got kind of some pseudocode here. I have my actual solution down below this. I don't want to show my solution. But here's basically what the query is. There's some query, and then I'm selecting an anonymous type. So that's select new thing, and it's going to have all of these fields in it. So there's an issue here. This is an anonymous type, which means my unit test cannot say, type X equals result of all titles, because there is no type. It's an anonymous thing. And then even further, I'm converting that to JSON, which is kind of just converting it into names and values, name and value pairs. So that adds another little interesting problem, where we just have to write our unit tests in a way that we kind of assume that the result has certain fields with, and then we can compare to the expected values. Okay, so let's write a unit test for the library. Here is the library, first of all. Here's kind of just the home page. Home page runs this all titles controller, And actually, let me refresh this. So I'll get my well, I have to, it's been running for too long. I have to restart it. I had it running intentionally so that I didn't have to wait for this, but so let's log in as Dan. Okay, same issue. Well, I'm not sure what's going on there. Oh. I do know what's going on there. It's because I have this set up for mocking, actually. So that's not actually going to work right now. But what I was just going to show you, I was going to refresh it so that we get that alert that shows the JSON that's returned. That's coming out of this query. Okay. But we can run tests on that. That's basically this result here, that JSON result, is the thing that we want to be able to run tests on. So I could say, make sure that there are make sure it's an array. Make sure there are 10 things in the array. Make sure that one of them is Doom or whatever. So we can do assertions on our unit tests. Let us write. Here's a unit testing project in Visual Studio. Let's start writing a unit test on that allTitles method. So it's a method of home controller, so I need a home controller object. Okay, so this is kind of happening automatically in the background when you run the web server. It's actually creating a home controller object. But in our unit tests, even without a web server, we can make one. It's not really tied to a web server. Then I can do something like controller dot allTitles. I can just invoke that method, and it'll give me some value back. So I'll just save that into into some variable. Then I could start doing something like assert.true, result dot something. I would want something like result dot length is equal to 10. So there are 10 books in my allTitles result. Problem is, so this is not working. Result doesn't have anything called length, because result it's an action result. It's not actually an array. We are returning a JSON array, but this action result thing is kind of some big abstract type with it's like an inheritance hierarchy. There are lots of objects below this. It's not directly an array, which is what we need. So let me comment this out for now. What I'm going to do is I'm going to say result equals controllers.allTitles as JSON result. JSON result inherits from action result, and I know that since I'm returning JSON, I know the result is going to be a JSON result. Okay. JSON result is intentionally typeless. It's not an array. It doesn't have a bunch of books in it. It doesn't have a bunch of patrons in it or anything like that. It's intentionally we don't really know what's in there other than by name. So even still, after converting to a JSON result, I can't do something like result at 0, because JSON result does not have indexing operator. So this is all related to just the fact that we're using dynamic types. All this stuff we're getting through, we can get a result out of the controller, but how do we actually use it? How do we assert anything about it? So we can't do that, but we do know that it is an array. We are returning a JSON array. A JSON result has this thing called value, which is basically the JSON object. So there are lots of other things associated with it, kind of meta information. But if I use result.value, that will actually give me the JSON object. So I'm going to do, we need to kind of save that somewhere, like var x equals result.value. Then we can kind of start asserting things on it. Okay, here's where it's going to start looking a little odd. We know that this result.value has certain things. We know that it's an array. We know that inside of it, it has certain things with certain names. But they do not correspond to the proper C# types because it's just JSON. So C# has this keyword called dynamic. And so this looks a little weird. I'm going to call it dynamic JData. The JSON data is result.value. And what that does, so JData is now a dynamic. What is a dynamic? Basically, it means it removes all type checks from the compiler. So I can do JData dot, and it compiles. This is basically this is me saying, well, I know what's in this thing. It's not actually proper C# types or methods, but I know that I'm saying that there is something called fk, whatever. So that is wrong. It doesn't actually have something like that. But I can now treat it as an array. I could access like JData at 0, or I could access JData dot length if it's an array. So here's what I'm going to assert now. I know that it's an array. I'm going to assert dot equal 10 JData dot length. So remember when I had that web page open that was showing all titles, there were 10 rows in there. There were actually 10 books. My all titles controller, I know that it's returning 10 things. Okay, so we can go up to test, run all tests. Okay, let's see. Oh, you know what? I'm not connected to the internet. That is why my web browser was not refreshing. I gave all kinds of wrong explanations for that. Turns out I'm just not connected to the internet. Okay, so our test is passing. Now that we know what was wrong with that, let me actually run this again to show you what it is that we're testing. Okay, that's what I wanted to show you. This is what our controller is returning. That is basically what we need to test. We need to make some assertions about all of this information. If I click OK, there are the 10 rows that I said there should be in the result. So it's the HTML, the view, is converting that big JSON thing into this. What I'm asserting now is that it should have 10 rows because I know there are 10 books in there.
So writing these tests and using dynamic, it seems like you require a lot of implicit knowledge about what's going to be returned by the server.
Yes.
Is there any way to create like a data object or something like that and strongly type the result when you get that?
Yeah, so the question was about like how we have intentionally removed types because we're using dynamic objects in JSON, which is what makes for all of this messiness, you know, all this weirdness. I'm using dynamic, and then I'm just kind of asserting that JData will have something called length. Yeah, maybe so. A cleaner way to do this would be to create a type that mirrors the dynamic type, the typeless thing that's returned. But then, that has its own problems. That kind of defeats the purpose of the dynamic type, and you might as well use those classes in your controller instead of select new. If you did that, that problem would go away. It's kind of a trade-off. Do you want this, or do you want to make a whole bunch of different types, classes, for every kind of different combination of columns that you're going to select? Okay, back to our unit tests. It passed. Let's go back to the home controller though, and let's just break it. So let's say return JSON, I don't know, something that's not even an array. I'm just returning the JSON of the number 5. And let's run the tests. Okay, so it fails, not because 5 is the wrong number or anything like that. Let's look at the reason for the failure. Int does not contain a definition for length. So the thing that actually got returned is an int, and I am using dynamic here, so the compiler cannot tell me that that's a problem, but then as soon as it tries to access something called length out of an int, that's where it fails. So you do just have to know, you have to get all of your stuff right, and unfortunately the compiler can't tell you if it's not. Okay, so take that back out so that we have a working, back to a working state. Yep.
Why do you use var result instead of JSON result?
Why am I using var here? No reason really. It was just faster to type in the moment.
And how do you know if your unit test failed because of a wrong answer?
So how do you know if it failed because of a wrong answer? It would explain it right here in the reason. Instead of saying int does not contain a definition for length, it would say something like expected value 10, actual value 9. Instead of throwing an exception, it would just be the wrong number. Okay, so that's great. We can make, let me just kind of rerun those while I'm talking after I've fixed it. So we can make a unit test, but this is going against a lot of the stuff I was just saying before this, which is I'm testing with the live database. This is the real library with 10 books in it. And the reason for that is, so let's look at, all I'm doing is I'm making a home controller, and then I'm calling controller.allTitles. So where in here am I saying go to atr.eng, use the library database? Let's look at the home controller again, and we'll scroll down a little bit, show you part of the actual solution. there. So using library context equals new library context. That is where it's getting the information about ATR. So let's look at that just really quick. Here's on configuring in library context. That basically means whenever you make a new library context and configure it in the default way, here's the connection string. So all of that stuff is hard-coded. Go to ATR, username, database, everything like that. That's why this unit test is going to the live database. But we wanted to go to a mock database because this 10, I just happen to know there are 10 things in there. What if the library gets a new book? Suddenly I have to go and rewrite all my unit tests. So what we want is something like, when I'm creating the home controller, I want to do something like, be able to like pass in a different like database connection. So instead of using the default, use some kind of mock. So I would then do something like library context mock equals new, and instead of just creating the default, I would put in some other parameter in there that says don't go to ATR, go to just an in-memory database. So that's basically what we need, and we can do that. This is not the actual syntax for it. Let's look at that, but let's take our short break first. For a live database, a couple issues with converting the types out and getting the right names out and everything, but we did it. It worked. It was great. And so here's what we've been doing, and what I've basically told you to do when writing a link query is just put your link query inside of a using block where you create a new something context, LMS context, chess context, whatever. And so the problem there is that the default constructor for a library context is going to use that connection string that you created at scaffolding time. So it's always going to go to the real database. So we need something, some way of creating a library context that changes where it goes. It'll be the same context with all the same models in it. It just will use a different connector. So one option might be, like inside of your controller, you could do something like, if we're in testing mode, make a testing database. Otherwise, make a default database. So let me go back and just kind of show you. Here's the home controller. Here's the query. And this is exactly the problem. So what I'm suggesting on that slide, what I'm suggesting you should not do is something like, if we're testing, or rather if we're not testing, then do that. And then you could have down below you're using, you could do like else, make a new library context with the mock connector. Your unit tests should not know, or your controllers should not know whether they're being tested or not. That, just super bad design principles there. So that won't work. Here's the problem, is all of our controllers are making a new connection using the default connection. So there would be no way to inject in a different kind of connection. So we need to not do that. Don't put your using block, don't create a new context inside of every controller for every link query you do. Instead, we'll associate the database connection with the whole controller class. There will just be one of them. And then all of our controllers, they don't need to do using, they don't need to make a new one, they'll just use the existing one. So as I'm showing right here, by default, we will create the actual database connection. And then in our controller, we just use it. So just start writing a query from x in database dot whatever. And I've not wrapped this in using. because database is declared in the whole controller class as a member. Okay, so that's basically all I've done there is, let me go up to the top of this class. I actually already have that. I have a protected library context DB. So the fact that my all titles is kind of creating its own right here, this is just name hiding. So I actually just don't even need this anymore. My whole controller has a variable called DB that was created with new library context. Okay? Yeah. So what's the point? It's the same, so far it's exactly the same as it was. But now here's what we can do. In the class, we can now say, I'm about to start testing you, so use a different context. So now in one place, instead of in every single controller where you would need some kind of switch, like if I'm being tested versus if I'm not, use a different context. Now you just say, make a function, use a different context. So I can pass in a test, a mock database context. Now that class-wide DB variable is changed for every controller. So in every controller, you would want to get rid of that using new library context and just use the single one associated with the object. You might be wondering why put a separate method like this, a use context method. Why not just like pass this into the constructor? And it's annoying, but the way the MVC web server works in .NET is it can only have one constructor. So it has to be the default. It doesn't have to be the default, but it's complicated to make a single constructor without like totally breaking the web server. So we'll just do it this way. We'll just make a method say like change your testing context. Okay. Now finally we can write a unit test. So what we need to do is make some mock database, which its type is just library context, but it'll have some different options. We make our home controller just as before, but now we say controller.use library context, so use a different context. And then we can start invoking controllers and making assertions and stuff like that. And now just kind of automatically, since I'm not declaring a new one right here, anytime I use this variable DB, if I've changed what that variable is, this controller will now use the mock database instead of the real database.
My question is, why did you, what's the point of using the using block in the first place?
Oh, what's the point of the using block?
Yeah.
That's just because library context inherits from disposable. So you want to clean it up anytime you're done with it. So, good question. Now it looks like I'm not cleaning up my database. So there's a little more I didn't show you. Since this thing, this iDisposable thing, is now, its lifetime is now the lifetime of the entire controller, my controller has to override the dispose method. So my controller is now disposable. So when my controller goes away, it disposes the database object. So I've moved all of that so that instead of creating one and disposing one for every controller, we just create one for the entire object and then dispose of it when it goes away.
Can you show how you're creating the mock database?
Yeah. So how do we create that mock database? And that basically just gets us right into kind of upgrading this test so that it uses the mock database instead of the real database. The code itself is a little messy and not too interesting. I've just got it copied down here. So I'm just going to take that and paste it into my controller. And we'll look at it a little bit. There's, just kind of some messy, long API names in here, but we'll look at the important parts. So we basically need this options builder. This is an object that's going to provide options to a library context. And here's the important part: optionsbuilder.useInMemory database. So that's what's telling it to, instead of using the default connection, make an in-memory connection. Here's another important part: use application service provider, new service provider. That is what's going to make it wipe out the in-memory database for every unit test. Otherwise, it would be kind of stashed away, and every unit test would use the same persistent in-memory database. This will make it reset the in-memory database every time. Okay, now I make a library context, and I just pass in those options. Instead of the default constructor, I pass in those options. Now my DB will be an in-memory database. Okay, create the home controller as usual. But then all I have to do is controller.useLibraryContext, that one that I specifically created with an in-memory connection. Now we're good to go. Controller.allTitles is going to return 0 results because this is a brand new empty in-memory database. So this is wrong. I can't assert that there will be 10 things. So what's missing now is I don't actually have any data. And that's kind of the point. I don't want to use the real data. I want to make up my own data just for the purposes of testing. So you can just start inserting things into this database using normal link. So I can just do titles t equals new title, new titles. T dot title equals fake book. Fake author. T dot, what else do I need? ISBN. I just need some 14-digit string. Okay, then I just do database.titles.add t database.savechanges. Just like the normal database. Same link stuff, except now it's just going to this in-memory abstraction of an actual database. Now I can invoke controller.allTitles, but now I know that there's actually only going to be one book in there, because I only added one book. And that will never change. That's the win we get here. I am now controlling directly in the test, in the unit test, I am controlling what data I'm testing. Everything else about it, though, is the same. Okay, good. So, nope, still building. There. So, test still passes, but it's not touching the real database now.
How does the server pass in a real database into home controller?
How does the server pass in a real database? You mean like the web server?
Yeah, like does it call use library context?
So what the web server is doing is this. The web server is going to make its own home controller, and the home controller default constructor is going to make this variable, which is a default library context. The default library context always goes to the actual database. And then I am changing that behavior with this call right here. My controller is now using a different specified library context. Any other questions, comments? Yes?
So, right now you're just testing with one controller method. Is it ever smart to test like a whole HTTP request?
Yeah, so right now I'm testing just the controller. This is completely separating it from the HTTP part.
Right.
And that's actually intentional. My goal here is to test the controllers, not to test .NET's web server stuff. Because we're not writing that code. That's all provided for us, and that's another thing along the same lines of we just have to trust the other abstractions are working. Yeah. Yeah. So this unit test class I am running separately. I'm not even running a web server. This unit test class, when I run this, I'm just clicking the Run All up here in this special Test Explorer window. I'm not clicking on Visual Studio's standard play button. Yeah, so it's a totally different program running. Okay. Let me get your thoughts on this test. This stuff's all kind of messy and verbose. We could move that all into a helper. What about this part? So all of this, pretty much this stuff. For my single unit test, I am setting up the data that I want to test against. But you could imagine writing many more unit tests that are similar that want to test against a very simple library with just one book in it. Instead of asserting that the count is 1, maybe you assert that the ISBN is correct or something like that. So you could copy and paste all of this setup code into every unit test, or better, you should just make a little helper method that's like, create simple in-memory database. So I am going to do exactly that. It will return a library context, make tiny library. Basically, I just want all of this. That's the setup part. Okay, everything in there except this is related to setting up the library itself. That actually still belongs down there. And then the only thing I'm missing is returning it. Okay. So all I really did there is just move some code into a helper. Now I can just do db equals make tiny library, and then I can set up my home controller to use it. Okay, yeah.
Does Visual Studio have setup and teardown the same as?
So does Visual Studio have setup and teardown? It depends on which kind of unit testing library you're using. This is XUnit. I don't know if it does or not. There are lots of, there's NUnit, XUnit, Visual Studios is just called I don't remember. XUnit is kind of like a third-party thing, which is actually why you might have noticed these aren't called tests, these are called facts. It's poorly named. There's a different kind of test in XUnit where you can kind of parameterize it. So instead of the test taking no inputs, you could reuse the same test on different values. But, to answer your question, I don't know. Does this have setup and teardown? Maybe. Okay, so now I could go write another test. Public void test2 it has to be a fact. First of all, this is very poorly named now, test 1. This should be test all titles count. Because that's what I'm testing, is that the count of all titles is correct. We'll leave test 2 just unnamed for now because we don't know what we're going to be testing, but I can now do this. VarDB equals make tiny library, and now I can just reuse that same setup data that just has this fake book in it. Okay, so actually instead of that, I have another one already ready to go. Make basic library. And in there, so this is just the stuff I copied and pasted. I have make basic library down here. Similar sort of setup, but it's just adding more information to the library. So there's a book, there's a patron, there are 2 copies of that book, so just like a more interesting, still very small, but now I have information in other tables. So with this library, I can actually test things like check out a book, because I have a book instead of just a title. And I have a patron, so I can have that patron check something out. All this other stuff is pretty much the same for most tests. So I'll just copy that. Okay, except for the controller that we actually want to run. So instead of all titles, let's test something that actually changes the database instead of just reading, like selecting data out of it. So let's see if we can check out a book. To check out a book, you need a patron logged in, because checkout only takes a serial. It doesn't actually say who is checking it out. It assumes that whoever is logged in is checking it out. So I'm going to do controller dot check login. Oops, not Dane. Okay. That will make my controller say that some person named Dan is now logged in. I could do some asserts on that, like make sure the login worked or whatever. We will just assume it does for this test, because that's kind of just a side effect. What we need now is we want to do controller dot checkout book. So we'll check out one of those copies of Dune. So serial number 1001, we'll check out that one. Okay. Now how do I know if it worked? Basically this controller, the point of this controller is it has some side effects. All it returns is success. So I can do this. Assert.equal true jdata.success, because that controller, let's go to it. Let's look at the comments here. Returns success. It's just going to put inside of JSON, it's going to put a value with a field called success and a value of true. Okay, but we also need to make sure that the side effects happened. So this will just make sure the controller returned the right thing. We need to make sure that there's actually a row in the checked out table. We can just start using link. Var query equals from C in database.checkedout. Select C. That's going to give me all the rows in the checked out table. Now I can just do something like assert.equal 1 query.count. Okay. So I can just write link straight up in here, even though it's not an actual MySQL database. It's connected to this thing called DB, which is a mock database. But link queries all work exactly the same. Okay? You could do another thing like, maybe assert dot equal for the card num of the person that has it checked out. Query dot to array at index 0 dot card num. Can't type today. And this is complaining because the two types of the thing you're asserting have to match, so this has to be a uint. But, go wild with your unit tests and assertions. Point is not how to write unit tests. Point is how to write unit tests when there's a database involved. Testing theory is still a skill that you'll be learning for many years to come, and one of the hardest things to get down as software engineers. Questions? Comments? Okay. We'll just end a few minutes early today. Phase 3 will go out at the end of this week.